Okay, if Mary can sit down in a seat someplace, we could begin. Nice fall, though. You recovered real good. Well, welcome everybody. Welcome also to our friends from the Geology Club that have joined us today. It's very, very nice. A couple of little announcements. We have on our Historical Society board a need for 4 more people. And when you only have 12 openings, 4 is a big void. So if anybody's interested in being on the board, we meet the second Monday of each month here at the Steeples, up here in this room, and at 1 o'clock. So consider that. Say it again. Oh, 1 o'clock. Mm-hmm. And the board meetings are open to the public, so if you just want to come and observe and, point your fingers at us, then we'll tolerate that. We do have our heritage guides on sale. Today we've moved the table in here, where at the end of our program we're going to have refreshments. And so we invite everybody to come up and have maybe a question and answer period with our speaker today. As usual, we'll pass the hat. It'll start in one end of the room and go the other, so that always helps us fund these kinds of things. So, Doug Walker is our guest speaker today. We're very honored. Evidently, several clubs in town have been trying to get him to make room in his schedule, and we were lucky enough to get him. Doug commonly says that he doesn't like to move. He came from Kansas. He's back in Kansas after a stint at MIT getting his bachelor's, master's, and PhD. He immediately moved back to Kansas to take the job at the University of Kansas, where he is now. Got there in 1985 and is still representing the University of Kansas. Doug's work has been on structural geology, faults and folds, and geochronology, dating in igneous rocks of many types. There are more 13-letter words in this introduction than I've said for a long time. So, in the mid-90s, he started a lot of work with the Geographic Information Systems, the GIS system, and has been doing that also. The GIS work is understanding the arrangement and organization of geologic information and data. Dave worked on several geochemical and geochronologicals.
Age.
That wasn't very good. It's age, evidently. And now is developing a mobile app for field geology. Doug Walker currently holds a position as the Union Pacific Resources Distinguished Professor of Geology, and was president of the American Society of the Geological Society of America from 2020 to 21. He teaches courses in structural geology, the history of the earth, tectonics, and statistics and linear algebra. We are very happy to have you with us today, Doug, and sorry for the long words.
No problem.
Thank you.
Thanks.
Welcome.
Well, thanks so much. It's a real pleasure to be here in Canyon City today. See a few people I know. See Kurt Sorensen, who probably can correct all the errors that I make about the history of the camp. So go for it. So this is the 100th anniversary year of the KU Geology Field Camp. And when it started, we'll get a little bit more background on that, but we're recognizing 1922 and 2022 as 100 years. and we had a celebration this summer. We brought a bunch of alumni out. We had about 100 people come for 4 days, and we did some tours. We talked about pastimes and basically celebrated the fact that field camp and field geology has been going on for a long time. Just to kind of start out, what do we do? I'm going to do a talk that gives you some idea what field camp is, what field geology is, then some of the history, some of where we've gone, some of the nuances of the field camp, and then eventually we work ourselves to today and then moving on to the future. Towards the end of the talk, I'll play a video that was put together by KU Media Services. They're professional videographers and photographers, and working with them was kind of amazing, and I'll explain that a little later, with people who really know what they're doing on that sort of thing. All right, so this is 3 students working out at the KU field camp. This is west of Canyon City in a place called Blue Ridge. And we're fortunate in KU Geology in that we had a fellow named Dan Merriam, who was the default geology department in Kansas Geological Survey historian. So he's written several books about the department and some of the people in this. And this came out about 12, 13 years ago on the story of Kansas Geology Field Camp. And in there's a quote from Roger Kaesler, who organized the camp for a long time, that the camp began operating in the Canyon City area in 22, and that's what we're taking as the first date. It actually started being taught before then, but was very irregularly taught. 22 is when the regular course was adopted and moved forward. And then we'll talk a little bit about the early years, 1937 to 1940, when the permanent camp with buildings got put together. So this is the quote from Roger. It makes it almost certainly the longest running geology field camp in the world is completely false. I don't know why he said that. There are many, many, many field camps, especially in Europe, but also in the US, that have been running a lot longer than the KU camp. But it is one of the old field camps for the US, not the oldest. All right, so this is a view of our camp. This is a picture taken in the 60s with Roger Kaesler's description. And basically, it's up the road to Cripple Creek. It's not quite to where the Shelf Road starts. It's at about 9 miles up the Garden Park Road. It's right across the entrance to the Dilly Ranch, the big sign that is there, and it's actually part of the Dilly Ranch Homeowners Association right now. It's a pretty rustic and Spartan camp. What you see in this picture are some red roofs on top of the hill. That's where the faculty stay, and some red roofs down in the foreground. Those are student cabins and a meeting hall. We'll see more pictures of those as we go on, and you can see a few cars parked there as well. So this kind of sets the camp up. It's a little more modernized, but not much from these pictures, and we'll see more of that later. But anyway, this area was ideally suited for looking at rocks, studying geology, and builds on a long history of geologic studies in the whole Canyon City area and this part of Colorado. But what I want to get this talk started with is just talking about what a field camp is like and why we do it here, and sort of give you some more information on why the University of Kansas, 500 miles to the east of here, would have property in Colorado to begin with and build buildings, etc. So really the field camp idea is it's a lot more than buildings. That's what we see on the ground. But geology field camp is the course where students first come out and really take all of their knowledge they've learned in classes and apply it in a very nice real world setting. So it's sort of the practical exercises that we can look at. One of the things that you'll often think about connected with field geology are geologic maps. This is an example of a geologic map from an area in California, and hopefully you can see there are little brown lines drawn on it. Those are topography. So geologic maps are usually stuck on a topographic base map, so you can know where you are because of that. And then all the symbology means something. The colors mean different types of rocks. There's actually color schemes. Geologist looks at this and already knows the age of the rocks without seeing any of the labels because the colors are standardized. So this is a set of skills that we develop as geologists, we develop in students, and then as professionals to be able to map rocks and map structures. For example, the bold line on here, the dark line showing, not the blue one, but the black ones kind of running upper left to lower right are faults. So identifying geologic features is a really critical aspect that we get practice in and then locating them on a map. So all geology majors take some sort of field camp. What are we teaching them? Well, we'll start out with something really simple. What do rocks look like in the field? This is an area near Twin Mountain, just northwest of Canyon City. And you can see the arrangement of rock layers here. What you'll see is the red rock in the middle. Looks kind of like Badlands weathering. It's a very fine-grained, shaly or muddy rock. Then you can see one thin bed of white rock and then one really thick package of white rock. This is the Harding Sandstone for any of the geology club people in here, anybody familiar with the local geology. But what geologists need to do is go out, look at that, and instantly know what rock unit it is, what age it is, and how that sand got moved into that position. We go out and then we say, okay, I recognize what the rocks look like. Now I'm going to have a cliff here and exposures of lots of more rocks. And you can see the layers, some of them thin, they're where the students are, on the back hill, very thick. And we want to know from this, how do the rocks form? What were the ancient environments that were here when these rocks were forming? So I hope a lot of you have been up Garden Park towards Cripple Creek with the Marsh and Cleveland quarries. The identification and study of the rocks that the fossils are in there plays a really important role in understanding the climatic conditions and the surface conditions where the dinosaurs were roaming around. We refer to that as paleogeography or geography in past times. And of course, connected with this, and we got geochronology as the first big word in the introduction. Geochronology is basically getting the ages of rocks. So you all know that you can do it from finding fossils and identifying the fossils, such as these dinosaur fossils up near the, this picture taken up near the Marsh Quarry. Other geochronology uses radioactive decay principles to establish ages, but that's something we need to do. And we go in and we teach students how to recognize different ages of rocks, how to appreciate the differences from, say, the granites in the lower part of Royal Gorge to the layered sedimentary rocks that you see all around us here. The next big question we come out, and this is a slide from California, is why are these rocks exposed to begin with? We all know that these sedimentary rocks are laid down. We have streams or oceans or whatever laying rocks on top of each other, depositing them. Now we can see them. Something has to happen. And especially, you know, with tilting of rocks that we'll see in a little bit, there has to be movements in the Earth's crust to bring these up and expose them. The rocks here are partially exposed because of changes in the Pacific Ocean. They're also partially exposed here because the Gulf of Mexico opened and allowed erosion to occur. So there's all sorts of complicated mechanisms that we try to teach students and try to understand. This is an example, again, a picture from California, but there are some similar rocks here in Colorado of jointed basalt flows. And I think hopefully all of you are aware of the fossil beds up at Florissant with volcanic eruptions. One of the questions that we try to address with students is how did the magmas, how did the molten rock that formed these volcanic flows come to be? How did the explosive eruptions occur? And what are they telling us about processes within the Earth? So again, we're bringing students out to try to understand some of that information. When we talk about uplift and volcanism and igneous activity, we also want to know when rocks are deformed. And this is from the North Twin area. These rocks are vertical. These rocks are Devonian in age. This is the Williams Canyon Formation for the Geology Club folks. But these are vertical and they're folded and they're faulted. So we go through and want to describe when that deformation occurs and how we can relate that to global events, local events, and understand the geologic history in a great amount of detail. We also want to get to where we look at images of the Earth taken from space or airplanes or drones or anything like that. This is a picture of the area up at Blue Ridge, west-northwest of Canyon City. And you can see the light-colored bands going through here. You can see in places that they kind of, I'll just go ahead and jump over here, very continuous, and then you get these areas where they're kind of funny looking. And then you come here and you follow this layer here, it actually folds back on itself and comes along like that. So part of what we're trying to teach students is just the wealth of images of the Earth that there are from all kinds of different satellites, different sensors that they can use to understand geology better. So these days, we really want to put this in action for the students so that they're able to use that and understand what's going on. So we really think about, I think about, and most geologists think about field camp as being the ultimate capstone course. It's the ultimate course that brings students into the field in an area they've never seen before, that they can then study and put together a geologic interpretation for. So it's very much the hands-on, ultimate summary course that a lot of students will take. And Canyon City has nice rocks that we can look at. So again, this is up at North Twin Mountain, just looking at some students and probably a faculty member on Ordovician rocks here. This is the Fremont that you see around the whole Canyon City area. It's actually in several thrust faults in this location and a lot of folds. It's a fabulous area to look at and to understand geologic development. This is just a beautiful area. This is the last project that students do at our field camp because they can put so much of their learning of the rock units and that together. So that's what you do in field camp. You go around and you look at rocks, you study them, you try to put together a geologic understanding that not only does the history, but uses all those things that you learn in geology, like how sand is deposited, how wind blows sand, how volcanoes erupt, how plutons or molten rock gets intruded into the Earth's crust. All right, so that's why we do field camp. KU has been teaching field camp for quite a while. So I want to go into now some of the history of development, changes over the years. There'll be some dates in here, a few old pictures, a few new pictures. When did this all start? Well, in 1892, the Geology and Mineralogy Department was established at the University of Kansas. And soon after that, the single faculty member in geology took the chancellor of the university on a field trip north of Lawrence, Kansas to look around at rocks. So that was pretty cool. But in 1903 was when the very first summer field course was taught. It was taught once in 1903 and wasn't taught again for many years. In 1922 was when the camp started in the Canyon City area. And it was taught regularly for many, many years after that. There were some interruptions during the Depression and World War II, but has been fairly well taught for the last 100 years. The first field camp was actually on the Canterbury Ranch in Garden Park, and everybody stayed in tents. And in 1928, Ray Moore, who was to be the future president of GSA, went out there and more or less put his seal of approval. He was very important and influential in the KU geology program. He put his seal of approval on our field camp, and basically it's been taught ever since the 20s. It was a different world. There were no satellites, there weren't any to speak of, there weren't really any airplanes, no aerial photography, and no topographic maps to speak of. The maps that were put together by basically surveying techniques, where you would use something to sight, measure distances and angles, and create your own topographic map with a fair amount of artistic license on them. This year at field camp, at our centennial, I talked to some people who had done this method many, many decades ago. I asked them how many observations or how many survey points could they put in a day, and the answer was maybe 20 or 25. And these days, with use of satellites, aerial devices, and LIDAR, for anybody who knows what those are, or for LIDAR anyway, rather than 25 points in a day, we can put something like 200 to 400,000 points on a map per second. So it's an incredible difference on being able to create topography. Roads obviously weren't as nice in the 1920s. This was the University of Kansas field vehicle, an ancient field vehicle, and some of the students who were out there working on the rocks that you see back behind. And again, noting from Roger Kaesler that this activity really started and pushed off in 1922, that the whole section here in the work in Canyon City area started. There are a lot of field camps in here for any of you who may know or may have run across other groups. For example, LSU, Oklahoma State, Georgia, University of South Carolina, Colorado State at Fort Collins, all run field courses out of this area. KU hosts a group from Lamar University for a short time at our field camp. And other departments at KU in the past have used our geology field camp facilities, including the geography department. So starting in 22, we had all these activities, and a lot of schools started doing their work around that time. The current site of the field camp, and I'll show an air photo a little bit later, started in 1927. Up until the in 37, up until that point is basically tents and moving around constantly. The current site where it is up Garden Park Road was identified in 1937, and the lease for the property, a 99-year lease, was signed in 1940, and it was part of the Freak Ranch at that point. The Freak and Dilly ranches are up there, as well as Canterbury Ranch. I'm sure there are people here who know the history of ranching and of the families in Garden Park much, much better than I do. Anyway, the lease was signed in 1940, and cabins were built with money that was donated by geology alumni. So when we started out, when the camp started out, this would have been a typical picture of it: tents, fires, etc. And then we move into cabins for faculty, students, and basically a place you can call home for 6 to 8 weeks, depending upon how long the course is run. We'll talk a little bit more about that later. So that's kind of the establishment of teaching in this area and the current set of buildings. So all the buildings there are over 80 years, well, sorry, we've built a few new buildings, but the original buildings are over 80 years old and still are quite wonderful to stay in. So if you have a bunch of people out, 10 to 20 students, you also have to provide food. And for the first couple of years, food was provided by the Idlewild Cafe in Canyon City. And the course fee for 6 to 8 weeks was $15. In the 20s, some of the faculty wives cooked. Dr. Shoei was the person who really started the camp in 22, and his wife cooked here for many years. Eventually, the cooking moved to a ranch house across the road with Mrs. Fancher cooking. They would serve breakfast and dinner every day. There would be sack lunches to take out in the field. And on Sunday, there was no lunch, just a big afternoon chicken dinner that was served. When Mrs. Fancher got tired of doing it, they went to the Canterbury Ranch to the south, and Mrs. Canterbury cooked for a while. The common theme, though, always nice sack lunches prepared for students to take out in the field. Water is also an important issue, and we all know in this part of the world water is critical. The first few decades at the current location, they pulled water out of the creek, out of 4 Mile or Oil Creek. They would put it in a settling tank to get all the sediment out of it, and then use it for washing, cleaning, and that sort of thing. Any sort of drinking water was brought up in milk cans from Canyon City. In 1953, the Kansas Geological Survey came out and did an electrical survey to try to identify a place to put a well, and that was identified in 53 and a well constructed in 60. So the water was put in 60 years ago. All the plumbing was then and remains above ground. So that limits the time that you can occupy the camp. Here's a picture of the sort of electrical survey methods that were used. Oops, trying to look into the subsurface for basically conductive layers where there would be water. The well there is, I think, one of the best wells, period, in the whole Dilley Ranch area. All right, so the camp history as far as the students are concerned. From 1922 to 70, there really aren't records that we can get to very easily. We know that a typical camp size was 10 to 20 students, with some years having up to 40 students. We tried this year with the Centennial to get the class rosters going back because they exist in the KU archives, but for privacy concerns, we couldn't actually get into those. Maybe we will someday. Starting in 70, things became better monitored, and you can see a peak in the mid-80s when there was the first really big oil boom. There were a lot of undergraduate majors, and that died down by 90, but you can see kind of a steady growth. So somewhere between 10 and 30 students is a typical class size for the field camp, along with a couple teaching assistants and 1 or 2 faculty members. In all, probably a bit over 2,000 students have taken KU Geology Field Camp in the last 100 years. So on average, around 20 students per year attend it, if you're using a 100-year average. One of the things that has really happened in this part of the world, as I know you all know, is that there's a changing landscape. And the landscape is changing not just because of geology, weathering, and movement, but mostly people. This is an old photo of Canyon City. This is a new photo of the Canyon City area. The growth has been tremendous. And with that growth, there are people living everywhere, which means that if you're a geologist and you want to go look at some rocks, it may be on somebody's property. So for the Canyon City area, we have had several of what we some of the prize field areas have gone away because of development, because of division. And so we've had to deal with that for the whole history. In the 20s, when we got going, it was pretty wide open country. You could camp. You just got permission to do that. 1940, the camp was leased and the buildings were built. It was basically property somehow controlled, sections of land controlled by the Dillies and Freaks. Basically, it's not very good cattle country, so you can only have a cow or so per acre, if that, on grazing. So the land was very sparse. As we go through the 80s and 90s, we start to see a lot of development in the area. And in 2000, what's called the Dilley Ranch was sold off and subdivided. So there are 80 members of the Dilley Ranch Homeowners Association. They all have 35 acres. So the Dillies sold off something like 5 sections of land and moved to Nebraska to farm cattle. KU purchased the land at that time. The alumni for KU came through and purchased the 35-acre lot that was identified with us. Another really big development was in 2018, and I talked a little bit about areas that we've lost. Basically sections that got turned into 35-acre ranchettes that you can never coordinate access to anymore. There's one fabulous area that I've referred to before as the Blue Ridge area up in the mountains west of here. A family had owned a section up there for many, I don't know how long, over 100 years. I'm going to say many decades, but they were the original owners, and they were looking to sell. But rather than dividing it up and turning it into 35-acre ranches, the family wanted to sort of keep it together. So they communicated with us a couple times, and we finally had an alumnus buy the land, a section of land up there in 2018, and we first went on it as our own property in 2019. It's a fabulous geologic area. When I do the exercises there and I take my data to my friends and show it to them, they're like, oh, this is perfect. This is a fabulous area. So we are able to preserve some of the areas that are private in this way, and also a lot of our target areas are on BLM land. So currently, if you look at the Canyon City area here, Canyon City, here's the Skyline Drive area. That's the hogback of Dakota sandstone, the Cretaceous sandstone that goes all the way around. This is where we're doing most of our geologic exercises here now. The northern part is Shelf Road. That's when you go off of the flat in Garden Park, you drop into the canyon and go up the road. We do some exercises up there. The field camp site itself is right here, 8808 Garden Park Road. So we own that, and then the Blue Ridge area is this area right here, and again, KU owns a good portion of that. On the south and east, it's all BLM, but all the good geology is either on KU property or BLM property. To the north of that, it's all divided into ranches. Then two of our big exercises are at North Twin and South Twin Mountain. 50 comes up through here, and 50 comes right up through here, through South Twin area. And those are just fabulous areas showing both faults, folds, and great structural geology. The Blue Ridge area are metamorphic rocks. They're rocks that were deformed about 1.5 billion years ago. Fabulous exercises there. And then we run a week-long exercise down here in the Temple Canyon area, south of Canyon City. So the development out here has been pretty heavy. Some of the areas farther west and around our field camp we've lost because of land divisions, but there are enough areas now, like Canyon City areas, BLM, Martin Marietta is an aggregate company that we actually, KU has ties to, who let us on some of these areas. So the question is, we've taught around here, we own a couple areas of land. We're still having to teach the field course with gas prices at $4+ a gallon. It's $100 and some every time you fill up a van with gas, etc. What are we doing for the long-term cost and stability of the camp? I think physically, as far as locations are concerned, we're good. What are we doing for long-term financial stability? Well, this fellow is Bob Harrison. He was a KU student who took the field camp in 1937. That's him on an outcrop in 1937, somewhere again in the 30s. This is a picture. The Harrison family was in real estate in Lawrence, Kansas, and the Harrison family made a gift this year to teach field camp in perpetuity. So basically, we own all the land, and they provided a gift to our endowment that should provide $50,000 to $100,000 a year to keep teaching the field camp, pay for student scholarships, etc. Every year we give out about $50,000 in student scholarships the KU students to come out here. When they're out at field camp, they can't be doing anything else. They can't work or do anything of that sort. Sorry about that. And so various alumni, and Harrison included, have given this money. So at some point soon, you may see this sign, hopefully not on the paved road, but if you come into the field camp, basically recognizing the Harrison gift. It was also the Harrison family that purchased the Blue Ridge section for their apartment. So incredibly supportive family that allows the camp to go on. Okay, so that gives you a lot of the history. What I want to talk about and kind of end up with on this is just talk a bit about what we do today and what the field methods are. So as you can imagine, field methods have changed radically over the last 100 years. In the 20s, the 40s, basically the students were making their own topo maps. Students in field geology were as much surveyors as they were geologists in large part. 40s to the 70s, topographic maps and air photos became available. You could locate yourself on topography. You could look at air photos, see where different rocks and even trees were located. So that became the way we started teaching our field camp. But once you go from surveying to locating yourself on topo maps and air photos, you've got this common theme that the students have to learn how to locate themselves on a map, draw contacts, and get orientations. This is a big job. So if you think about students being out in the field doing surveying, they're actually putting points down where everything is. So it's an accurate way of displaying information, just really slow, really tedious. And then when you get topo maps or air photos, then all of a sudden you have a map base you can work on, but you have to figure out where you are. Where am I is like the constant question that students have in dealing with topography, trying to locate themselves. There aren't any street maps. Instead of streets, all we have are topo lines, and you have to look at those, figure out where the hills are, valleys, washes, etc., to be able to locate yourself. So this constant theme of locating yourselves has been going on for a long time. Basically, another faculty member at KU and I in the mid to late 90s, Ross Black, decided that, God, we really suck at teaching people to locate because they all come out, they spend 2 weeks there, and we're never happy with where they get to at the end of 6 weeks. So we thought, we're just awful teachers, we don't know how to teach that. Maybe if we started using GPS and GIS, we could have them locate themselves better. They could teach themselves how to recognize where they were. So in '99, we started using GIS in the field with students. The idea was that we would teach them to locate, they would teach themselves how to find themselves on maps because they'd have their location and they could keep comparing around to the world around them. And so by 2005, we had a very fully functional system with location. In 2015, we started to put together a mobile application for this. The long and short of it is that letting students teach themselves was a complete failure as well, because once they knew where they were by GPS, they were no longer interested in trying to figure out how to locate themselves on the map. So we got money to do that, but again, another failure. This is kind of the first GIS group that went out. These are a couple students in the 1999 camp. They were carrying these 10-pound computers that with 4 batteries would last a day of use. That's what one of them looked like. You had the GPS on the side that you could locate yourself with. We went eventually to much smaller computers. These are drawn to scale, 3-pound Panasonic computers that work quite well, and they ran good GIS software. Students were able to do that, look at data management. We went as far as having all students equipped with computers out in the field, and everybody was networked together. We ran a field network so that the students could communicate with each other. We could look at their maps while they were working in the field. I could actually draw on students' maps while they were in the field. It was all really, really cool. Again, another failure because it didn't really help teach anything. We did this for 1 year and then stopped doing it. It was technically possible, but in practical teaching terms, it didn't add anything to what the camp was doing. So nowadays, we have students working, still making measurements with compasses, but also using mobile devices, in this case, an iPad, to collect measurements and pictures and take data in that way. So the last part here, I'll just kind of finish up with the aspirational part of our field camp, where we're heading at this point. And the idea of virtual rocks and using mobile devices for learning in the field, virtual reality, has seen a lot of work on it in the last 10 years, really in the last 5 years, a huge amount. And what we're heading to today is trying to put together an application that the students can use that will allow them to understand both geology and location. So what I want to do now, if it'll work, is play a video here. It's about 3 minutes long. This was put together by KU Media Services. It gives you a little bit of feel for what happens in field camp, but also some of the new technology developments.
We're currently in Colorado. We're out here for field camp. It's a 6-week program.
What's a typical day for students out here? What do they do all day?
Basically spend 9 hours outside in the sun observing literally every piece of rock that you're stepping on.
Just looking at a bunch of rocks.
The KU Field Camp first started in the 1920s and basically has been coming back to the same spot almost 100 years now.
The idea is we take students out, they can see what rocks do in real life, which can be really quite complicated.
I mean, there's just no way you could study any of this stuff without being here in Colorado, actually seeing it and walking on it. Like, we're staring at what we're studying. There's no question about how hands-on geology is. It's awesome.
One of the best projects we have at this field camp is a project in an area called Blue Ridge. The rocks are different than anything they'll see as an undergrad in Kansas.
It has a set of very different rock types in a very small area.
The major things we're looking for are the different rock types, so we can put it on a geological map.
We're using an app called Strabo that's been jointly developed by KU and a few other schools. It's very user-friendly. It really does break everything down.
The GPS will locate you within about 5 meters of yourself. From there, you can draw in the contacts.
Instead of us telling you to bring here pen and paper and mylar and different colors and all that kind of things, you can literally do all that in an app.
They can add images, they can add data. Everything is basically in that device. So that's pretty nifty.
One of the real rewarding things about teaching field camp, I think, for everybody involved is just that we can come out, spend time with students.
They're all very good professors. None of them put themselves on a pedestal or anything like that. They're all very down to earth and they're always willing to help you.
When I see the lights go on with a student and they get something, I think that's the most rewarding thing for me.
It's great to have peers right next to you like this entire time.
It's so immersive in the people that you're with. There's no way you don't walk out with connections. And I think that's what kind of the best part about it is the people.
almost anybody who has an undergraduate degree in geology and you talk to them about their favorite course or the course they're going to have the most memory of, it's going to be field camp.
It's such a great experience because I have friends that go to other universities and they just don't have field camps, because how are you going to learn the geology if you're not thrown out into the field and have to discover it for yourself? I wouldn't know how to consider myself a geologist without going on this trip.
All right, that was put together by KU Media Services, kind of as advertising, kind of as endowment, but I think it gives you a pretty good feel for what the students look like in the field, a little bit more about what the camp looks like, and just some of the things that they're doing on a day-to-day basis, and some of the things that we're moving through on technology. So here we are at the main building in camp, a small meeting room. And what we're starting to think about now is how do we modernize the camp? How do we make this a much better and a much more shared experience? Frankly, we've been there 100 years. We were able to get 100 alumni to come out to a big celebration, and we're going to do some fundraising. Naturally, and try to raise some money to modernize the camp. First, make the camp 3 seasons. So the first thing we want to do is just bury the water lines. We could come out in March or come out in October, November and teach if we wanted. So getting a 3-season camp would be great. We're also thinking in terms of making the camp much more accessible. And I've been talking with a couple groups in Canyon City and the Pueblo, Fremont County area to try to use, if we did modernize the camp for people who couldn't walk, people who can't see. Can we do something for people with disabilities? Disabilities can happen at any age. And also, can we appeal to the community? Can we appeal to the greater Fremont County community? We've got the Harrison Field Station, we're calling it now, that will last the next 100 years. What could we do to improve the camp? Accessibility is always a challenge whenever we're dealing with field geology. When we had a couple people from Canyon City come to our field camp, basically they were in wheelchairs and we met them at the end of our driveway because after the end of the driveway, there was nothing that was accessible in our entire camp. So using mobile technologies and trying to teach in this way is becoming very, very important. What we're imagining is putting together a teaching facility that has a classroom where people can come in, anybody can come in, that our cabins get modernized a bit, so that they're more comfortable when it's 100 or when it's 30. And also that we can put together a couple fully accessible facilities that people could come in wheelchairs. They could stay in there. There would be shower facilities, bathroom facilities, etc. So the idea is that we could move forward with that sort of accessibility. One of the things that really got me thinking about this was the South Canyon Trails project. And when I've been down there working in the Temple Canyon area, just seeing the fabulous trails that are there that go right past outcrops, that go right past things we have students work on and measure. There's no reason these days that somebody with something like a trail rider or something else could that people who couldn't walk could come out here and do field camp. It might be a different overall experience, but they would see rocks in the field and be able to put things together. And we could work with all of these different groups that involve both accessibility and outreach for the community. So you get a bit of the history of field camp, also a bit on where I hope we're going over the next 5 to 15 years in teaching field camp and broadening it out. So that's it. Thanks. So I guess I'll take questions, or we'll go have something to eat.
Well, if we have a couple of burning questions, we can do that now and then gradually move in and have a nice glass of nice lemonade to cool ourselves off a little bit. So,
Sorry. So the rocks around Blue Ridge, the granites up there, are about 1.72 billion years old. The sediments that are metamorphosed and deformed with those are somewhere between 1.7 and 1.4 billion years. And actually that hasn't been well established even today. And the deformation up there is probably around 1.4 billion years old. The Pikes Peak batholith has a couple intrusions associated with it that come into the Blue Ridge area. And they're like the youngest part of all the rocks out there. So there's a little, just a whiff of that coming through. So tuition, so the way the course works is we have 2 3-hour courses. Each is 3 weeks long. Tuition is about $1,000 for each course. The course fee is about $1,000 for each course. So altogether around $4,000 to $5,000 would be the fee. There's alumni support to cover all of the student course fees. So $2,000 of that, if the student just says, I want my course fees covered, and hands in a note, they'll get that paid. And essentially any student that wants scholarship will get some kind of scholarship. One of our alums was Dean McGee of Kerr McGee, and he gave a scholarship gift, and his gift letter says he never wants to have a student not go to field camp because they couldn't afford it. So there's support in that. Kurt. Yeah, no, and that's going to keep it going. And like I say, we're expanding to other groups at this point. You know Zhigong Li in your department, the geography department, does remote sensing. Oh, you don't know him? Okay. Well, anyway, he's coming out, and maybe the geography department is going to start using it again for physical geography and remote sensing. And it's all open for anybody. Okay. Yeah, we should be able to pay for things at this point. The annual, just the upkeep and TAs, utilities, gas, vehicle maintenance is about $50,000 a year for the camp. By the time everything's done. Some years there's almost no maintenance. A couple years ago we had to put in a new, replace the well pumping system and the water system, and that was about $20,000 to $25,000 to do that. So the cost goes up and down, but there's expensive things that come in all the time. Yeah. So they're not freshmen. They're generally juniors or seniors. What a lot of students did is they would put field camp off to be their last course. So they're a senior, they've taken all their classes, they take field camp, and then they graduate. And about 25 years ago or more, a group of us was thinking, you know, this field experience really helps students all the way across. The camp then was 2 4-week camps or 2 3.5-week camps. So it was a bit longer. And what we did is we basically said, let's get freshmen out there. So we carved out a 2-week camp. And then we said, okay, we're going to encourage juniors to take field camp if they want to. And so we've kind of moved the whole thing up so that all the geology majors can have field experiences starting, if they take an introductory course, they can take this 2-week field course. It's in Colorado, it's here for a couple days. They go to Dinosaur National Monument, Rocky Mountain National Park, etc. They do a lot of different geology. So we're trying to get them in younger. So in 2020, I had about 12 students signed up for field camp. COVID hit, so we basically said only seniors needing to graduate can take it, and we had 5 and then 3. So it was more than half were taking it a little bit early. Yeah. Okay, so women at field camp. There were women in the 30s and 40s. They had to have chaperones, and there were separate cabins for them. About 10 years ago, so there are a couple cabins. We separate out by sex in the cabins at camp. There are 2 cabins that women use, 3 cabins that men use. The course is typically kind of half and half men and women these days. About 10 years ago or so, a woman named Maisie Steiger, who took the camp in 44 or 45, who has a lot of money and is old and is very, very nice, donated money to build a couple more cabins for women. So now we actually have the Maisie Steiger Women's Cabin Complex, a couple new cabins with that. So they go, well, as you saw in the video, they're just out teaching, they're doing everything. I mean, there is no difference, and there really hasn't been a difference probably since the middle 50s as far as the camp's concerned. As far as jobs, coming out with a BS in geology, people can work for environmental firms, hydrology firms. They have the training to be able to do some jobs of that sort. I would say that about 1/3 of them go on to get master's degrees, and the master's allows them then, oil companies become interested in them, larger engineering firms become more interested in them, and then some go on for PhDs. Right now, one of the things that's happening with geology at KU is that we have a satellite campus in Kansas City where we get a lot of professionals coming in for advanced training. We're running something called a Professional Science Master's Program, which is a 2-year, mostly online, but some practical applications where somebody who has a bachelor's degree and has been working for a while could come in and get a retool for a master's. And right now, 80% of the students that are doing the hydrology course are actually non-traditional professional science master's students who are up there right now at our field camp. Does that take care of that? Okay.
So if we could just continue our discussion, if you can join us
Sure.
for a little social time. You can go in through this, you can open this door, you can also get in there by that back door. So let's come in here, small token of our appreciation.
Well, thank you so much. It was my pleasure.
Our pleasure.
Thank you.